So, hello students. I hope you all are doing well. So, in this video, we will cover uh, E2 E2 reaction. E2 reaction. In previous video, uh, we have discussed we discussed about E1 reaction. So now we we will discuss about E2 reaction. So it is also same like SN2 reaction, but it is an elimination reaction. And here it is a one-step process, one-step process, and the rate of reaction, it is a second order reaction. Second order reaction. Why? Because the rate of reaction only depends on alkyl halide and the nucleophile, concentration of nucleophile. So now we will see the mechanism because it is an important part of the reaction. So the mechanism here. So here we can take any nucleophile, any substrate like alkyl halide, like CH, hydrogen. Here this hydrogen, and here is any living group. So first, it we as we know that it is a first one step reaction. So the nucleophile, like we can take any nucleophile like OH minus. So it will take an hydrogen from beta carbon, and simultaneously it will remove this living group. So here we only get a transition state, like here carbon and carbon, hydrogen is whole halogen. Okay, any living group is there, and it will remove this hydrogen from here, this nucleophile. So this is a transition state here that we get, where simultaneously this is capturing this hydrogen, this nucleophile, and also this living group is removed from this carbon. Then we get the final product, which is our alkene, because as we know that it is an elimination reaction. So this is the final product. So here we this E2 elimination is also called trans elimination. Trans elimination. Why trans elimination? Because the living groups should be anti to each other. Like if it is anti or trans, then this occur more readily than cis, which is more 20 times faster than cis if they are cis position. Like we can take an example. This carbon-carbon double bond. Then there is a chlorine, which is a living group. There is hydrogen, chlorine. So, like if we take a base like NaOH, OH minus will remove a hydrogen from here, and then this will live as a living group. So it gives us a alkyne. So as we can see that they both are trans to each other, which is faster than if they are at cis position. Like if we take an example where they are at cis position, like if this attack this OH minus, which is a nucleophile, if this remove the hydrogen which is cis to living group, then this will slow down the reaction, because as we know that it is around 20 times faster than this second one. Now we will see the reactivity of alkyl halide. Reactivity of alkyl halide. So it is same like E1. As the more uh, steric hindrance there, the elimination will be it will easily occur, like 3 degree, 2 degree, and 1 degree. So here, if it is um, more crowding is there, then elimination occur easily in E2 reaction. So what about stereo is its orientation? Stereo specific and stereo selective. So this is it is also stereo specific because that this nucleophile attack from a specific direction, like it is it where this transposition, and stereo selective because it gives us a selective product. Okay, like whether it is a Setsev or Hoffman. Now we will see the effect of base. Effect of base. So it this reaction is favored by strong base, strong Bronsted base like RO minus, OH minus, CN minus, RCOO minus, NO3 minus. This is the order of the basicity of nucleophile. Now the effect of solvent. So as we have seen that the solvent in E1 reaction it was polar protic. So here we use polar aprotic. Polar aprotic like DMF, dimethyl formamide, DMSO, which is dimethyl sulfoxide. These are the polar protic solvent. Another one is about leaving group. So good leaving group should be there. It will increase the rate of reaction like CF3, CF3, SO3 minus, MeSO3 minus, HCOO minus. This is acidic type nucleophile, phenolic type nucleophile, OH minus. These are the this is the order of leaving group. So now let's see the difference between E1, which we covered in previous video, and E2. So substitution of the substrate, like it should be 3 2 1, 3 degree, 2 degree, 1 degree to stabilize the carbocation, and it is also E2 is also 3 degree, 2 degree, and 1 degree. Uh, in this E2 reaction, transition state stability is the key factor. Leaving group and good leaving group should be there. In both the reaction mechanism. Here we use weak base It favors this even reaction here. Strong base, and it favored by polar protic solvent. Protic solvent. It favored by polar protic. So I hope this video may have be helpful for you. So thank you for watching. Now we will meet in our next video.